Hey, welcome back. We were talking about Martian Math really recently. This is a Flickr album I have with a lot of my ideas for teaching synergetics, which is the Bucky Fuller stuff, using a storyline of Martians coming to the Earth or ETs, however you want to do the story. It's kind of like science fiction backdrop for having didactic cartoons, meaning or they don't have to be cartoons, but the animations or live action, whatever, it teaches some math while you go. So you're not just entirely in a fiction mode in that sense. So the Martians come and the Earthlings, and they decide to build a dam together. And this is a chasm across a canyon, and that's the dam slowly going up. And they have to pour concrete. So that's like a bucket of concrete that goes out over the dam. I've seen actual dams being built like this in Lesotho and Africa and places. I mean, it's common. U.S. has a bunch. North America. So anyway, the Martians they measure volume differently. In fact, they multiply differently, and that's kind of what this video is about. When we learn multiplication ourselves, it's always the two lengths are going to be like a L. I'll put it down here. Maybe we can see better. And so if you go start with an L as your two lengths, and then A times B is a rectangle like that, right? But the Martians, they start at 60 degrees, and A times B, you just close the lid, right? And if it's volume, you start with a tetrahedron with the three lengths that you're multiplying, A times B times C, and you just close the lid. So let's see, I've got a picture. That explains what's going on with these diagrams here, or you see this chopsticks or something with a line across. I'm just showing in the workshop setting how it is we can multiply two numbers in a way that's like different from the 90-degree based. Here's the tetrahedron drawn really huge, apparently. Aircraft land on this runway, so it must be really big, tethered by chains in the desert somewhere. As it fills with water, it fills 1, 8, 27. In other words, the volume numbers are what we're used to. We don't change the arithmetic, we just change the model of multiplication. You can think of using a V sign as opposed to an L sign, if you want to think of it that way. And that's what's going to help you understand how we get a mite of, you know, 1/8. Because if you sit down and do your calculations and say this has an edge of square root of 2 or root of 2, and this has a diagonal of 2, if you say those things and then tell them the volume is 3, they're going to go like, what? What are you talking about? The volume is square root of 2 to the third power, right? Because you take the edges and multiply them to get a cube, but we're doing this like in the picture. And so we get different answers, but it's all self-consistent. Along those lines, I would say that this is all like New England transcendentalism is what brought this to us in the form of Bucky Fuller. So it's kind of ironic that Boston, the home of Cambridge, Harvard, all that, they don't really talk about in their recent decision in the public schools to switch from the Mercator projection to the Peters projection. The journalists were pretty shy about saying too much about this projection back here. This is the Fuller projection, and it has the same virtues as the Peter projection. Actually, it's a little more virtuous, and in terms of distortion. I mean, these really are the right sizes, pretty much, best that you can do on a sphere. How that projection is developed is graphically summarized here. It's not just orthonormal or whatever. Bob Gray's done some good research on this map. It's really just about as accurate as the Snyder projection. Thing about the Dymaxion projection, well, for one thing, it's the classic arrangement of the continents. There's no cuts into the continents. And at the center, you have like the North Pole. So I call this a global warming map. It used to be the Cold War map because we were showing where the missiles would fly when both sides, superpowers or whatever, launched. They would like over the, And then it was good for jet travel. People didn't understand why would you go to Detroit to go to Shanghai. Well, because as you can see from this map, the shortest way from the United States to China is to fly like that. So, it makes sense to go from Chicago to Shanghai just as much as you would, people think they have to go out over the Pacific Ocean or something. That wasn't very accurate either. So the Mercator had its problems, the Peters has its problems, and it's really politics as to which map gets a lot of focus. And right now, like I say, the Bucky stuff is kind of subversive, kind of verboten. It can help you to want to learn math, even just to know that it's a little bit counterculture and not just what your grandfathers and grandmothers, well, they're the ones who probably do know this stuff, because Bucky Fuller, he died in like 83. He lived from the 1800s, late 1800s, till all through almost all the 1900s. So a lot of this is familiar to viewers here, but not everyone. So do keep in mind that there are subcultures out there, ethnic groups that teach their kids a little bit differently than maybe you were taught. I mean, we know that. We learn that. It's anthropology. Get National Geographic. But sometimes it bears repeating. And I call them Martians, okay? But they don't have to really be Martians. I'm not, really a Martian. So, let's talk some more. I'll give you more synergetics as time goes on.